Okay, let us go ahead and get ourselves started again. A really interesting question came up at the break, and it's a really kind of one, it's one that makes you think for just a little bit in terms of why something works, is the whole notion of the Sunpass location. And really, why does this work? You're looking at the sun, and the sun seems to be just a few hundred feet away from the building. Okay, and we're adjusting relative to that Sunpass location, and something about the math really makes you scratch your head, but intuitively, we do sort of know it works this way. So you got to sort of like figure out why that works. And let's talk about what the Sunpass location is returning and really how it's used in the calculations, because I think that'll make it a little clear about like why this works. Okay, so I'm going to open up that same file right from where we were last time, and see if we can address this. Okay, so again, we had set up all this interesting infrastructure based on the idea that there's some vector that goes from a plane, which is sort of fit to those panels, and heading out towards the sun, and really what the distance is between those two different things, kind of comparatively as vectors. The sun path, let's see if I can bring this open again, is there. See if I can run it. You see, it returns these values, just negative 68, negative 49, 53.68. It's returning this XYZ values. Those values aren't actually the location of the sun. Where those values are, that's the location of a vector kind of pointing towards the sun. Okay, so what happens is, even though those values seem very, very low, and the sun is truly, thousands and thousands of miles away, okay, that vector still holds true, even though it is so far away. And really what even happens here in terms of the direction to X, Y, Z, okay, what that's really doing is just evaluating those two different vectors, relative to each other. What's happening here is it's really taking a distance between this one and that one and kind of drawing a line between them. And then we're just basically going through and computing a distance. And what is that distance? That distance is, it's really the distance between the points on that line to really sort of figure out really where the biggest and the smallest is. So what's really happening here is, if that's the normal, and this is the sun, okay, and what's happening is there's some sort of vector in here. Yeah. What this is doing is basically at some point, and I'm not sure it's exactly where the point is, it's just basically computing that distance. Okay, and we're really using that as a surrogate for this whole notion of, what the alignment is. My suspicion, if I actually go through and dig into it, is that this is all just sort of based on the whole notion of the origin of the project and really, where these different vectors would line up relative to that. So it's really as though all these things were just really normalized, like back to that origin. But it sort of works as a relative scaling thing. And what's kind of strange is, as you sort of think about the sun and the sun being in the sky, even though the sun is a relatively fixed location, okay, what ends up happening is, because the Earth is moving so quickly relative to the sun, okay, it's as though this, it's all a question of your frame of reference. We're moving the sun in the sky. The truth is, we're moving under the sun, but it really has the same net effect one way or the other. So that this whole notion of the solar model and really how it is able to return accurate vectors relative to where we are on the Earth's surface, that's actually true. So I don't know. It's definitely, it's a real head scratcher in terms of trying to explain why it works, but it does, in terms of just being able to give us some computational values. Okay, so let us go ahead. We're going to continue with this just a little bit further. That is, we got this thing that's actually responding pretty nicely now. And right now it's just doing this thing where it's kind of changing the size of this opening and stuff like that. But we can start imagining something much more interesting happening with our adaptive parts in terms of things growing or rotating or somehow responding to the location of that sun. But I want to go a little bit further in terms of giving you some feedback and a really useful scale or way of approaching, giving yourself some feedback here. And that's to actually do something called adding a color scale to this. So just kind of give you a sense of the hot zones and the cool zones, stuff like that. So we're going to add just a few more functions to go through and put that together. We're going to add a color node and define a range of colors, then map that into the elements. Okay, and that's really where we'll complete this one. So if you can, I'm going to shade that again and go back over to Dynamo. Let's kind of talk about adding that. So the deal is here, we have all these fantastic values. We could use the strength value 0 to 1. We could use the strength value that's been scaled down. We could use either one of those values. We just have a different range of values, that's going to relate to each of those different panels, describing sort of this notion of either the raw strength 0 to 1 or an opening that's been scaled out of it. We'll probably just use the raw strength 0 to 1. Okay, and out of that, here's what we can do. We want to go through and just define a range of colors, and then within that range of colors, go through and map those based on the strength. So let's talk about how you do that. The color node looks like this. We can feed in some red values, some green values, some blue values. Okay. What's the alpha? And alpha is always a little bit strange to me in terms of how it applies. I always think about the alpha channel and having transparency in the background, but I don't know, I'm not really good on colors, so I'm not sure what the strength of different alphas is. I think it is almost like a transparency sort of variable. Yes?
Why do you use red, green, and blue, and not red, yellow, and blue?
Oh, that's interesting. That's a really good question. That just has to do with colors are defined on computers. I don't know. It's just the mixing of the red, green. Yeah. To be honest, I don't actually know the answer to that. It's just we always talk about RGB and how the mixing of the light as opposed to the mixing of the paints. Does anyone know that?
Yeah, primary colors. Yellow is not a primary color.
How can that be? It's
no, because you make green from blue and yellow.
See, I think of it the way you do in terms of like paint colors.
Yeah.
But in terms of light.
Okay.
Yeah. Raj, you have any insight on this? This is. What's that? Anyone? That's a good question. If anyone knows the answer to why when we're defining computer colors we use red, green, blue as opposed to red, yellow, blue, I'd be very curious to know the answer because I don't really know that one. Okay, we're going to go through and just fill in some values here. If I fill in values of 0 for all these different things, and I'll just use a single node, see what 0 is. I never remember if 0 is pure black or pure white. I think it's just pure black. No, it's actually probably pure white if I think about it. I'm just going to fill in 0 first, them all first. Okay, so I have two different colors that are actually amazingly similar right now because they have the same values. Okay, so I just have color 1 and color 2. They're all defined as 0. And just to sort of satisfy my curiosity about really the different, what they are, I'm going to go ahead and put in color range. Let's see if I can get a little map. Okay, so I can put in a starting color. I can put an ending color in there. And with any luck, come on, compute for me. This sounds a little strange in terms of what it does. I want you to compute. It should be computing. That should be fine. That generally works for me. It should be returning a color out of the tail end of it. Now, we'll keep going. It's gonna update at some mysterious point here in a moment. Okay, just to actually sort of play around and have slightly different colors, let me go through and change I'm going to put another number in here, just the 255, so the strongest strength. Again, 0 to 255, not 1 to 256. There's all these things about why this is that way. I'm going to make this one associate that with a red color. I'm going to associate this one with a blue color. Because what I'm trying to do is just get a range of colors. So I'm kind of going from like a strong red to a strong blue, is what I think is happening right now. Or I could actually be the exact opposite right now, but we'll figure that out in a minute. Okay. What I want to do is, out of this color range, go through and, based on what it's doing, stop there. Okay. What we want to do is actually go through and map this, okay, onto the different values that are, being returned as the functions for the strength. Here's the value. What does it expect here? The value of the value between 0 and the selected color. Oh, let me try that for a second. Hang on. 0 may just be giving me a whole lot of 0. I'll do another number node in here. Okay, 0 is looking like black. 1's looking like black. That's not looking very good. You over here. Let's try this again. I think if I'd done it the other way, because I seem to have some very black things here. Let me try mapping the 255s to the others. And I'll apologize for this. I'm just very bad about remembering what the directionality of this is. Again, not updating the way I want it to. This slider in here. Gonna make it just go from 0 to 1. I'll think about that, why it's happening, in just a second. Let me do this, because I always kind of keep background ones hanging around here. Let me just open one up to see if I can get a little help. Any favorite changes? Sure. And go back out to, I think it was at step 5 when I did that. Doing a little recalculating, let it come on back. Doing too much recalculating. Okay, let's see if I can find this now. Nope, I have to go to the last one, which is my step 7, or step 6, excuse me. Okay, 0 for most all the values, 255 for the other value. No, that's kind of the way it's supposed to be. We'll let it be. See? And that's what it's supposed to give you, is basically this whole notion of, okay, so what is it? 0 for all the values, 255 for the blue, 255 for the red, and it gives us this nice little color range. So let's see if we can make that work, because it should work. Okay. 255 for the blue, 255 for the red. Open that up. Oh, now it does. Again, I'm going to write this off to like it doing weird things in terms of dynamo to sort of fight me. So what I'm going to do is, again, go through and associate 0 with most of them. And I'll associate 0 with most of these. Okay, but now it seems to be going from just blue to red, and I have this number slider. So in theory now, when I pull this little slider around, we should be able to see different colors in there. Oh, it looks like it's being pretty slow about computing it. But it looks like I'm going to get a value, or a range of values going anywhere from like just pure blue to, it looks like it should be pure red. Oh, it looks like it's green right there, but we'll see how it actually looks on the finished model. I'm a little iffy on this node in terms of like how its functionality works. Okay, what we want to do finally is take that range of colors and actually just map them in to the different elements. And what we can do is actually use just this great function called map. And what map does is this. It lets you take any sequence of numbers, any list of things, and what it'll do is basically feed that as a function to something like the color range or some other function, and just return values. It'll return parameters back out of it. So it really just, it plugs a lot of values through some function and returns a list of values at the tail end of it. So what we can do is take that color, and the color is actually the function, because we want to take this list of values from 0 to 1 and plug them through that 0 to 1 as the inputs. We can go through and take, let's get rid of that since that's not helping me at all. In terms of the sequence we want to pump through this, what I want to take and actually use these is, it's values that go from 0 to 1. So it's not going to be the strength values that got scaled down and flipped. I'm going to use the 0 to 1 values that came directly out of the scaling function going from the high to the low. So I'll take those values and I'll plug them into this mapping function. Let me pull that down a little bit so that it looks a little easier to follow. And just as a note, these nodes can really be anywhere you want to. I just tend to sort of string them out left to right because they're a little bit easier for me to read that way. But I can take this and feed that in as a sequence. Okay, so in theory now, what I'm going to get is a whole series of different color values. So for each of the different panels now, they have some color value associated with them in terms of the red, the alphas, the red, green, blues. Okay, and based on this, we should be able to kind of see something on the object. Now, in terms of where they are on the object, we're going to do this final thing right down here, which is override the element color. That's going to map a color on there. We could go ahead and sort of put in some sort of an instance variable and try to kind of map the color that way. This is just kind of a graphic override right on top. And let's take a look at that. So what we can do is override element color in the view. So what are we going to do? We're going to basically take a whole bunch of colors that have been mapped and a whole bunch of elements, so I can find the elements. They're back over here, and bring those in. And now, when it recalculates, it should go through and change the color of all those elements so they correspond to that mapping. Oh, it's interesting. I got, let me clear it. I got the multiple values because I opened and closed the project several times in terms of bringing up different scripts. Let me kind of, again, take all these out. Take those out. Let's go ahead and rerun this. That's interesting. This is just giving me, it looks like mostly yellow values. And that's kind of disappointing. That's not what I want at all. So let's see if we can figure out why that is so different in terms of what's going on. Somehow, I clearly am not doing the mapping of the colors very well right now because I'm going through and varying, it's kind of like the intensity of the color, but I'm not actually changing the colors. Let's see if we can figure this out. It should be there. I'm mapping, then the range, and the values. Oh, did I flip it the other way? Let me try this. Based on my little notes, I think that perhaps on this, let's see what this is. The process used to map the elements, the sequence to map over. That would seem to be right. Although, as I'm looking at my notes over there, it looks like I'm supposed to be flipping. Yeah, yeah. Oh, say again? In the bottom? Oh. Oh, very good. So this one here, and then alpha was supposed to be 0, 2. Okay, so now it's red to blue. Okay, so should be a slightly better range now. Yeah, let's talk about that. The flatten completely, that's all about when we have a list. If it has any sort of order to it, it just sort of flattens it out. And I skipped it here because I don't think I need it. But let's kind of check and see if we really do in some ways. Really, where that got used originally, it's in this list that's coming out over here. Yeah, it's just a series of different values there. Okay. So in terms of those different values, if there was anything going on in terms of like any hierarchy to it, it would just sort of flatten it all out and say, just make it an ordered list, just a list that doesn't, it's not subsetted and grouped in any way. That's what flatten completely is. So in our case, let me just kind of put it in there. We'll see if it makes any difference. I don't think it will, but let's see. What flatten does is it takes a list. Okay, and if there's any order in the list, okay, it just sort of, makes it just a flat list again, as opposed to putting it in there. So I don't think it's going to make too much of a difference to us here, but the way it was originally done, I did have it that way. Let's see if we can figure out what's going on in terms of this range of values, because my range of values is not very exciting here right now. Yeah, that's not looking nearly as dramatic as I'd like it to be. So how about this? Let's go ahead and take a look at those scaled values here. Well, I guess it's sort of in there. What the values are right now is, this is kind of, if I look at the values, they're going anywhere from 0 to, it's 0.75 to 0.95. The lowest is 0.4. So what I'd like to do is think about over in here. You can see there's some variation between the red and blue, but not very strong. Let's go ahead and think about even there, like how we could amplify that effect. Because in terms of this range of values there, it looks like most of our values are kind of down on the low end. Let's try this again. Because in theory, if I put the number in here, the value between 0 and 1 of the selected color. Okay, so if I go through and put 0 in there, in theory that should give me like a single color, as opposed to give me a range of colors. It looks like it's trying to run. That doesn't seem to really do what I want it to. This is giving me all those values. They're varying on the blue dimension. The red dimension is still so strong in terms of what's going on. I'm trying to think about scaling it somehow. Because what I really want to do is, I'd love to get sort of things that are more, my guesstimate is that 0 is the blue side, the higher values are in the red, and that's why we're not getting much variation in there. We're sort of, staying down, and if you look at these, most of these are down in the lower range over here. It must be in the 0.89, something like that. That's the only one that's kind of hanging around at 0 right now, and that's the one that's kind of completely aligned to what's going on here. So let's kind of see if we can scale this a little bit in terms of what's going on. If we took, as opposed to just kind of those values, let me get rid of that one there. Let's see if we can come up with again, a function that's going to do a little of just kind of making those values look a little bit better. Just give us a stronger effect. So how about this? What if we took the scaling value, and what could we do? We could multiply it by, what is it? Let's see. It's right now, it's mostly in the 0.8, 0.9. We'd like to spread that out across the whole range. So we could do something like, if it's greater than 0.5, then we're going to go through and subtract 0.5, then multiply by 2. That'll sort of spread the range. That sort of makes sense? So let's see if we can do this. If scaling is greater than 0.5, okay, so that's on the high side, somewhere between 0.5 and 1. What we'll do is we'll take scaling minus 0.5, okay, and multiply that by 2. Otherwise, we'll just put 0 in there. Let's try that. So that's, again, just a formula to try and kind of amplify the effect a little bit. So if I use that formula, and I basically take out those scaling factors, let's see what that gives us. That's giving us a bunch of values now between 0.5, 0.7, 0.9. Okay, that looks a little stronger in terms of the effect of it. It sort of multiplied that a little bit. Let's take that and we'll use that for the mapping instead. Still not as strong as I want to in terms of what's going on. Let me do the other way, which is the 0 to 0.45 way. Let's try taking as opposed to that. Well, it's interesting because it's really, the values between 0 and 0.9, they seem to be pretty good, but just the strength of it's not all that good. Let me try this. I'm going to really just try and zoom in on a specific scale. Again, running it. Looks like it's trying to run in the background now. Although, this is one of the things where, see, it's kind of just hanging there right now. I have a suspicion that perhaps it's just hanging up a little bit in terms of what's going on. Let me do the save as, and I'll reopen this because I'm a little bit distrustful when things like that happen. Dynamo, let's open up that mid-class one. Oh, now it's a little bit more dramatic in terms of what's going on. I think what's happening is in this case, yeah, you can sort of see I'm just playing around with the scaling factors in terms of doing it. Yeah, I think it was basically kind of stuck and not doing very much for me in terms of what's going on. Let's go back to the 0.5 again, because I think that was probably an okay scaling factor to put in here. So again, I'll put in if it's greater than 0.5, subtract off the 0.5 and take the difference, and the ones that are valid and multiplying by 2. If I can run that. Okay, now I get a little bit more variation in terms of what's going on. So go ahead and play around with that a little bit. And the idea is, again, just to give you some visual feedback. In this case, it's kind of flipped probably from the way I think about it. I'd probably like the hot spot to be where the sun is hitting, the cold spot to be the bluer ones that are further out there. We kind of flip the color around in terms of doing that. But hopefully this is giving you some sense of really how you can use that notion of the sun's location to go through and change these things and even get some visual feedback on them. Okay, let's go ahead and move that one more time, and then we'll adjourn for the day. Where we're going next time with this, we'll see if that'll actually update itself. Actually, probably have to say run automatically to make it do that. Or run. Check to make sure that since I've opened and reclosed this, that the sun path is still actually tied to something. Again, it's not. Now it is. Okay, where we will go next time with all this is we're having fun with surfaces, breaking them up and doing things like this. We're going to come at it from a different angle next time. If you want to look ahead, you can start to see it with example 7.2 in the folder. But what we are going to do is say, hey, this is all fine, but let's start thinking about creating real Revit buildings out of this. So how we can actually go through, use the generation of a little bit of geometry to go through, and actually we're going to start creating like a little soccer stadium. Okay, so it's going to be, we'll work on sort of the shape of the bowl and kind of the outer form of how that'll work, what percentage will be covered by seating behind the playing field, okay, and then use some big super trusses that we'll put in to go ahead and support the outer shell, and actually put panels all over that shell that will actually respond to the sun and stuff like that, okay? So that's where we're going. It's going to go from this we're playing around with geometry to kind of creating a real building very, very quickly. Okay, and that's what we'll do on Tuesday. Okay, in terms of assignments and things like that, I got to write up the next assignment in terms of what we're doing. I'll meet with the TAs. We'll figure out what we're going to do. We may send it out over the weekend just so you get a chance to sort of start on it in terms like that. So we'll see if we can get something written out. But you can imagine what it'll be is something similar to what we've been doing in here. Basically taking some sort of surface form, panelizing it somehow, putting some adaptive components in it, tweaking around with the instance variables, maybe giving some color feedback or something like that. But you pretty much have the essence of what it's going to be. It's just a matter we'll figure out what kind of interesting form to have you work on it. Okay? Make sense? Then let us adjourn for today.